अस्सलाम वालेकुम एवरीवन। क्या हाल है आप लोगों का? Yep, 2 is the correct answer. Good job. काश ऐसा क्वेश्चन पेपर में भी आ जाए। ये पास पेपर से एक क्वेश्चन था. This was a question from past papers only. Obviously not the only question of logs, but yeah. Khair, anyway. So as you guys can see, we're doing logs. Now I plan on doing the concepts also, but what we'll do is we'll just go over the concepts, like a summary of all the concepts. Logs is basically about rules. Okay, you have a lot of rules about logs, so that's what I plan on doing. I plan on going over all the rules, and then we'll do past paper questions. So we can spend as much time as we can on past paper questions. Okay. Yeah, it was a 1 mark question. You're right about that. Okay, anyway. Let's start. कैसी तैयारी है वैसे आप लोगों की एड मैथ्स की? Or are you guys secretly praying that the exam gets cancelled? I hope no one's doing that. सर मेरा मंडे को एग्ज़ाम है P1. मंडे को P1? What exam are you talking about? If you're talking about, I'm pretty sure it's not math or ad maths, okay? But I can't give you any tips for a subject I don't know too well. So we got lots of time before ad maths. At least I have, yeah. That is true. Sir, paper 1 is in such a stressful week for commerce students. Yeah, I heard. I think it's back to back with business. Sir, threshold prediction about 0580. What paper are you talking about? वैसे तो doesn't make a difference because I've forgotten exactly what came in the paper, so I don't remember. Sorry. It's too soon to say anything about. I mean, not too soon, but yeah, I don't remember the paper, so I can't really say anything about the threshold. Anyway, let's start, shall we? So, as you guys can see, we're doing logs. Okay, so we'll go over all the concepts one by one. And before we start, I'd really appreciate if you guys would like the stream. So here we go. And I'll share this folder with you guys, this PDF with you guys once we're done with classes. Okay, so you guys can download it. You'll find the link to the topical past papers, by the way, in the description. Okay, you'll find it there. Okay, so there are around 10 to 11 rules of logs. Okay, and honestly, if you have a good grip on all the rules, then the whole chapter becomes easy. Now, I'm not saying that the rules are easy. Yes, they're challenging, but not all the rules are challenging. Only like 2-3 rules, especially change of base law, reciprocal law. Those are the challenging rules. Other than that, it's pretty easy. Okay, but it requires practice. Only after practice will it become easy. Otherwise, it won't. So, let's say you have log A, B. Okay, so it's important for us to understand that how exactly do we read this. Okay, like for example, when you have 2 to the power 3, so that's how it's read, right? 2 power 3. Okay, we don't call it 2 3. So just like that, it's not advisable to call this as log AB. It's best that you call this as log A base B. Okay, so this is read as log A base B. Okay, so A is basically the argument. Okay, it's the argument of log, and B is the base. Okay, so that's how we read it. It's important to know this. Okay, now the first rule is how to convert. So this is conversion here. So let's say that you have log A base B, which is equal to C. Now, at the moment, this is in log form. Okay, so log a base b equals to c at the moment is in log form. Okay, or you can say logarithmic form. Then you can convert this into index form. Okay, so how do we convert this into index form? In index form, here's what happens. Now, the base remains the base. Okay, the value that you have after the equals to sign becomes the power, and then it's written equal to a. Okay, so here's how we do it. B remains the base, but c becomes the power on the base. So b to the power c equals to a is how you write this in index form. Okay. Now it's important to know how this works both ways, not just one way, but it's important to know how this works both ways. That is how to convert from log to index form and how to convert from index form to log form. So let's do a few examples to get the hang of this. So I'll do the examples over here on the side. So let's say that you have log 8 base 2. Now basically you can evaluate this. You know how? This is trying to ask you a question. Sorry about that. Yeah, so this is trying to ask you a question. This is trying to ask you that what should we raise to 2 so that it becomes 8, okay? Or rather, if 2 is the base, what should the power be on 2 so that the answer turns out to be 8? And we know very well the answer to that is 3, okay? So this is in log form at the moment. If I wish to write this in index form, what is that going to look like? 2 to the power 3 equals to 8. And that makes sense also. 2 power 3 is in fact equal to 8. So let's do another example. Let's say you have log 16 base 4, which is equal to 2. Now again, if you want to write this in index form, what will that look like? That will look like 4 square equals to 16. Okay, now like I said, remember it works both ways. So let's say you have log 1 upon 9 base 3. So again, this is trying to ask you a question that what should be the power on 3 so that the end result is 1 upon 9. We know very well the answer to that is minus 2. So if you write this in index form, this means 3 to the power minus 2 is equals to 1 upon 9. And yes, 3 power minus 2 is equal to 1 upon 9. It's not minus 9 and it's not minus 3, anything like that. It's 1 upon 9. Okay. Sir, is this for no, it's not for 4024. Beta paro to kya likha hua hai? It says at maths. It's not O levels. I mean, it's not math. It's O level / IGCSE, but it's not maths, it's at maths. Hello sir, we are writing mock exam in 2 weeks. Any tips you have for just keep practicing. Okay, that's the best tip that I can give you. Okay, did I miss anything important? No, I didn't. Okay, so that's the first rule. Okay, the first rule is about conversion. Okay, how to convert logs. Then comes the second rule. The second rule is about how do you keep a log function defined. Okay, so the second rule is how do you keep a log function defined. So log function to be defined. Now there are two rules. Okay, and ये नहीं कि दोनों में से कोई एक पूरा होना चाहिए. Both the conditions should be fulfilled for a log function to be defined. Okay, it's like, you know how you can't have a negative value inside the square root because that's mathematically not possible. So just like that, you need to follow certain rules in order to keep a log function defined. So let's say you have log a base b. So there are two rules. Number one is that the argument should be greater than 0. Okay, so let's write this down in words, that the argument should be positive. Okay, and doesn't have to be an integer, it could be a decimal also, but it has to be positive. So that's rule number 1. And rule number 2 is that the base should also be greater than 0, but we don't leave it at that. At the same time, the base should not be equal to 1. Okay, so the base should be positive but not 1. क्या होगा वैसे अगर base 1 हो जाएगी? Question for you guys. What happens if the base is equal to 1? What's the problem with that? Yes, integration, we will do integration. So I'm starting off with easier topics because there's a lot of time left in AdMath. So we will so I have integration, differentiation, trigonometry, functions, all the main topics. I have those lined up, don't worry. And vectors, kinematics, that also. So like I said, don't worry about it. Sub lined up. Now let's do let's look at rule number 3. And in the meantime, you guys have to answer my question that what's the problem with the base being equal to 1? Now comes rule number 3, and that is if the if the base and the argument are both equal, then it's equal to 1. Okay, and it doesn't have to be a specific value, it's true for any value. So for example, if let's say you have log 3 base 3, that's going to be equal to 1. If let's say you have log 5 base 5, that's going to be equal to 1. If let's say you have log p base p, that's going to be equal to 1. Okay. Okay. Then rule number 4, which is if the argument of any log function is 1, then no matter what the base is, the answer is going to be equal to 0. Okay, the answer is going to be equal to 0. And why is that? Again, if you look at it, this is trying to ask you that what should be the power on a so that the answer turns out to be 1. So we know very well that anything raised to the power of 0 is equals to 1. So here we have, let's write this down, that log with base, sorry, not log with base, log with argument 1 is equal to 0. Log with argument 1 is always equal to 0. Okay, remember this rule. Acha, we don't worry too much about कि rule इस्तेमाल कहाँ से होंगे or anything like that. Okay, let's just keep writing them down. Log 1 a equals 0. Log 1 base a equals to 0. That means if you write this in index form, what will that look like? That's going to be a to the power 0 equals to 1. And again, that makes sense also. Okay. Now let's write down rule number 5. Now rule number 5 is what if you have log a base b, and on a, on the argument, you have a power which is c. Okay. So what happens is this, that c gets multiplied by the entire log function, c into log a base b. So let's write this down in words also. The power on the argument gets multiplied by the entire log function. So that's rule number 5. Okay. Acha, just make a note of one thing, and that is if you have log, and by the way, this works both ways. It's not that it works from left to right, it works from left to right as well as from right to left. Okay, so it works both ways. I'll write it down over here, and that is that it works both ways. Okay, depending on the need. So we look at the question and then we decide what is it that needs to be done. So just make a mental note of one thing, in fact physical note of one thing, and that is if let's say you have log a base b to the power, the whole thing is to the power of c, this is not equal to having the power only on a. Okay, these are two different things. So we use a different rule over here, we use a different rule over here. They're not equal, so just make a note of that. Okay, so when do we see this rule in action? So for example, if you have something like this, log 8 base 2, then what you can do is you can write this 8 as 2 cube, okay, and the base is 2, and 3 gets multiplied by the entire log function, and log 2 base 2, as we know, is equal to 1, so the final answer is 3. Okay, now without using any of the rules, the answer was 3. Using the rules also, the answer is 3. So no matter what rule you use, as long as it's perfectly applicable, the answer will be the same. So what about, okay, what about log argument 1 base 1? Not possible, because you can't have base as 1. Okay, that's not possible. Okay, so all right. Chem क्यों याद दिला रहा हूँ? Chem मैंने कब याद दिलाया? Where did you see chemistry over here? Do you guys use logs in chemistry? I don't think so. Back in my time, though, there was no logs in chemistry. So if you have any log with base 10, so we prefer to write it as LG. Okay, so when you don't write LG, you know how when we say root, we don't necessarily write the square root. Okay, we don't necessarily write the 2 outside the root because it's understood. So just like that, if you have a log function with base 10, so you might as well write it as LG here. LG ka matlab that the base is predefined as 10. Okay, so log with base 10 is called LG. Log with base 10 is written as LG. Okay, and which is why you will notice that LG10 equals to 1, and just like that LG100 is equals to 2, and just like that LG1000 is equals to 3. Okay, now here's a question for you guys. If LG1000 is equals to 3, what can you tell me about LG1 upon 100? What is that going to be equal to? Okay, so now you guys solve this question while I'm writing down the next rule, which is rule number 7. That log with base e is ln. Log with base e is written as ln e, which is why, it's just written as ln e in this case, which is why ln e, but in some calculators you have to categorically write down the power on e, and you'll notice that the answer is 1. And why? Because the base is also e, the argument is also e, so the answer is 1. Okay, so I can see someone's given the answer. Elisa, -2. That's correct. Good job, Elisa. -2 is the correct answer. 10 to the power -2. Yep, Hasib, you're also on the right track. Just need to change it. Okay, yeah, good job, Huzefa. Oh, reversible reaction. Oh, okay. Okay, I remember now. Yeah, this symbol is for reversible reactions. Yes. So, कैसे पढ़ते हैं आप लोग chemistry? I never liked chemistry. Okay, now rule number 8. So rule number 8 is, okay, now we're gradually entering into some complex rules. Okay, so if you have log a base b plus log c base b, so log with same bases, if you're adding them, what happens is that the argument gets multiplied. So this is also known as the product law or the product rule. Okay, normally in differentiation we say product rule, in logs we say product law. Okay, but makes no difference. Okay, what's important is that you know how to apply, how and when to apply this. Okay, so you can write this down in words that when two logs, two or more, actually it doesn't necessarily have to be two, but yeah, two or more logs with same basis are added, the arguments are multiplied. Okay, then you have quotient law, and in it, if you are subtracting two logs with same basis, in that case what happens is that the quotients get divided. So I'm just going to copy paste this and change the words. Change a few words here and there. When two logs with same basis are subtracted, the arguments are divided. Okay, there you go. That's rule number 9. Okay, then we have rule number 10. Now, rule number 10 is also one of the most important, and also a rule that students struggle with the most, and that is change of base law. Okay, change of base law. Now again, don't worry about when do we apply this or what exactly will a question look like. That we'll see when we start solving questions. So if let's say you have log a base b, now what you can do is you can rewrite a log using a third base, a completely independent base. Okay, and in that case the argument remains the argument, but the base also becomes the argument, and you now have a new base, a new common base, which is c. Okay, so that means this you can also write as lga upon lgb. Why? Because the base of lg is 10, or you can write this as ln a upon ln b. ठीक है, इसकी एक example देख लेते हैं. I'll do it with values so that you guys can see why this works. So let's say that you have log 64 base 2 divided by log, let's say 16 base 2. Okay, now अगर हम उनको individually evaluate करें without using the rules, so log 64 base 2, that means what should you raise 2 to the power of, so that the answer is so what should you raise 2 to the power of so that it becomes 64? The answer to that is 6. And what should you raise 2 to the power of so that it's 16? The answer to that is 4. So answer क्या आ रहा है? Answer आ रहा है 3/2. ठीक है, log 64 base 2 is 6 and log 16 base 2 is 4. So the answer is 3/2. But what if I use change of base law? If I use change of base law and acha, wait a minute. Sorry, just a second. Let me rewrite this. I skipped a step. Okay, let's do that again. Let's say you have log, yeah, let's say you have log 64 base 4. Okay, yeah, now this is correct. So what I'm going to do is, वैसे तो you can see the answer is 3. Why? Because 4 cube is equal to 3. But what if you use change of base law? So let's rewrite 64 as base 2, and let's rewrite 4 also using base 2. So log 64 base 2 is 6, log 4 base 2 is 2, and 6 upon 2 equals to what? 6 upon 2 is also equal to 3. Okay, so you can see that even if we change it to a completely different base, the answer still turns out to be the same, which is 3 in this case. Okay, now where is rule number 10 used? Like, how do we identify that it has to be used? Okay, so don't worry about that. When we're doing questions, that is when you learn how each rule is used. So we'll do plenty of questions, so don't worry about it. Now let's do the second to last rule, which is rule number 11. Yes, I can repeat this law. So basically, if you have log 64 base 2, so notice that at the moment the base is 4. So what I'm going to do is, I'm going to turn 64 into the argument and 4 also into the argument. Okay, and I'm going to give both of them a new and a common base. So the base that I've chosen is 2. So log 64 base 2 divided by log 4 base 2. Now if you evaluate log 64 base 2, that's 6. If you evaluate log 4 base 2, that's 2. 6 upon 2 is equal to 3. And if you had done this without using any rules, you would have gotten the same answer. Okay. Alright, now here's rule number 11, which is called the reciprocal law. Now this is like an extension of change of base law. Okay. And this also is very important. If you have log a base b, and if you take the reciprocal of the log function, so basically what you end up with is this 1 upon log b base a. So you end up changing the argument into the base and the base into the argument. Now if you're interested in finding out why this works or why this happens, so this is the reason why. So basically log a base b means, if let's say we rewrite them and we use a different base, and the base that we use is a. Okay, so this becomes log a base a divided by log b base a. Now what's log base a equal to? That's equal to 1, and now we have 1 upon log b base a. So this is why it works, in case you were interested in finding out. In case you're not, then just remember this rule right here, this rule. Okay, now the final rule. Okay, and this is the rule that we use to solve logarithmic equations. So if let's say you have log a base b, which is equal to log c base b, so in that case what we can do is, we can, because they both have the same base, both the log functions have the same base, so we can ignore the base and compare the arguments. So in that case, a is equals to what? A is equals to c. Okay, now these are all the rules. Okay, I haven't done any complicated questions yet. These are just the rules. This stream will be till 8 o'clock max. So are we going to do past papers? Yeah, we're going to do past papers, and this will be posted, don't worry. We'll do past paper questions. I'll post the notes as well. Okay, and the solved past papers as well. Okay, now, so let's look at, now this is not a rule, this is just something that we need to learn, and that is how to solve exponential equations using logs. So just give me a second, I need to restart the app. It's stalling for some reason. Okay, here it is. Yeah. So, as I was saying, solving exponential equations using logs. So when do we identify that we need to use logs? So for example, if let's say you have something like this, 2 to the power x, which is equal to 8. Now here you don't have to use logs, okay? Why? Because you know very well that you can write 8 as a power of 2. So 8, when you write it as a power of 2, is 2 cubed. So if we ignore the bases get cancelled out, and now we have x equals to 3. That's your final answer, okay? So there was no need to use logs over here. But what if you have something like this? Like for example, what if you have 2 to the power x, which is equal to 9. Now you can't write 9 as a power of 2, okay? Now because you can't write 9 as a power of 2, what you're going to do now is you're going to have to use logs, okay? Now how do you use that? Let me explain in a minute. Okay, so how is logs used over here? So what we do is we normally use LG. So we introduce LG on both sides. So let me make you guys write this down step by step. Okay, so step by step, this is what we do. Here's the first step. The first step is that you apply LG or ln on both sides. LG or ln on both sides. Okay, now let's do the first step. So that means you have LG 2 to the power x, which is equal to LG 9. Okay, then the second step, which is that you multiply x with the log function. Multiply x with the log function using, I don't remember what rule, but yeah, using a certain rule, x gets multiplied. So you have x LG2, which is equal to LG9. Okay, and then the third and the final step, and that is make x the subject and evaluate. Make x the subject and evaluate. So if you make x the subject, you have LG9 over LG2, and then if you evaluate this, let's see what happens. This is what happens. Now make sure that you have identified the key in your calculator where you have just log. Okay, and where you have just log, in that case you don't need to write down the base yourself. The base is pre-programmed as 10. So LG9 divided by LG2 turns out to be 3.1699, which if you write down correct to 3 significant figures, it's equal to 3.17. And there you go. That's your final answer. Sir, logarithmic and exponential graphs करेंगे. Not in this stream. करेंगे, but not in this stream. Don't worry. Sir, can you teach NCR questions where n is to be found too, please? Okay. I have solved so you'll find those questions in binomial mostly, and I've solved a few questions. I've solved such questions. You'll find it in binomial. Sir, can we also convert it to base 10? Yeah, of course, you can do it like that also. Okay. Linear law. Okay, linear law I'll do later. Not in this stream, but later on. Sir, but I've already made lots of videos on using on calculator tricks for math. I've made a few for AdMaths also, but that was last year. I'll make a few for this year as well. Okay. Okay, now let's do one more example question before we head towards past paper questions. Now here's part B, and let's say you have e to the power x minus 1, which is equal to 7. Now whenever you see something like e, in that case it's best to apply ln on both sides. So that's what I'm going to do. I'm going to apply ln on both sides. Ln e to the power x minus 1 is equals to ln 7. X minus 1 gets multiplied by the entire log function. So we have x minus 1 ln e, and ln e, as we know, is equal to 1. So that means x minus 1 is equals to ln 7. Now here's my advice, that is first make x the subject before you evaluate it. Okay. Now x is equals to ln 7 plus 1. Now let's figure this out. Ln 7. Make sure that when you're plugging this in your calculator, you close the bracket after 7 before you write down the plus 1. So the answer turns out to be 2.945. So 2.95 is the final answer. So there you go. That's your answer. Okay. Now as far as the concepts are concerned, that's all there is. Okay. What we're going to do now is we're going to do past paper questions, and we're going to try and solve as many past paper questions as possible. मैंने attach किए हैं past paper questions, as I mentioned earlier. Download them. Okay. And let's get to work. Now, here's the first question. Now, initially, you will find yourself struggling with deciding what rule to use, but once you solve like 20, 25 questions, then it'll be easier for you to identify what rule you can use. Okay. Now it says here, express LGA plus 3LGB as a single logarithm. Now how can I express it as a single logarithm? Now before I express it as a single logarithm, I have to first make sure that, अच्छा चलो पहले तो ये करते हैं कि let's ask how can we express this as a single logarithm. So in order to express this as a single logarithm, we have to make sure that whatever log function that we use with the three values that we have, okay, or the three expressions that we have, okay, you have to make sure that they have the same base, because only if they have the same base can you simplify it. If they don't have the same base, you can't simplify this. Okay. Now, as far as LGA is concerned, we have LG over here, nothing to worry about. And then as far as 3LGB is concerned, there is a rule that we can use over here so that we can simplify it, and that is, remember I said the power rule works both ways. The 3 becomes the power of the argument, so we have LG B cube. LG B cube. And what should I do with 3? What should I do with 3? Sir, can you also make okay, no, I think I've answered that. Yes, I will make videos on integration, don't worry about it. Integration is integration, differentiation, trigonometry, functions, logs. So I plan on making videos for all the important topics, okay? Don't worry. Okay, now as far as 3 is concerned, so what if I multiply 3 with LG10? Why? Because we know from prior knowledge that LG10 equals to 1, okay? And multiplying 3 by LG10 will not make any difference. Why? Because LG10 is equals to 1. And we're technically multiplying it by 1. So like I said, it makes no difference. But what that does is, it allows us to simplify. It allows us to use a rule of log, which we can use to simplify this. Why? Because 3 becomes the power of 10. So this is equal to 10 cube. And 10 cube, as we know, is equal to what? Is equal to 1000. So this is what we have. LGA plus LGB cube minus LG 1000. So this can be simplified. Since we have the same base, they can be multiplied. So LGAB cube minus LG 1000. And here also we can use quotient law and write this as LGAB cube upon 1000. And there you go. That's your final answer. Okay, now let's do another question. Here it says express log 2 base x in terms of a logarithm to base 2. So basically we have to use change of base law. Okay, we have to change the base to 2. Now you can do this directly if you want by using the reciprocal law, or if you want to use change of base law, okay, then you can do that also. If you use reciprocal law, then here's what happens. This becomes 1 upon log x base 2. And there you go. That's what we were supposed to do. We've done it. 1 upon log x base 2. That's your answer. Now let's do part 2. Now questions like part 2 are very common. Okay, and this is a nice question in the sense that it's asking you, it has made you it's made your life easy by making you do part 1, and it's also telling you exactly what you need to substitute. Okay, so basically the main part of this question is this, the substitution. Okay, now before we use the substitution, now notice that u is equals to log x base 2. So that means this is what can be replaced by u, but what do we do about this? This is not log x base 2, this is log 2 base x. So here's what we can do. Let's rewrite this as it is. Log x base 2 is equals to 3 minus 2 log 2 base x. Before I can use this rule, because before I can substitute log x base 2, I have to make sure that it is log x base 2. Okay, so log x base 2, isko banane ke liye main kya karunga? Isko banane ke liye we'll have to take the reciprocal. So log x base 2, this we can replace with u easily. Okay, and this first we need to write this as log x base 2. Okay, and now we can easily replace it with u. So u is equals to 3 minus 2 upon u. And now we can take the LCM and cross multiply and get our answer. Now I will not suggest that you take the LCM. I would suggest that you take minus 2 upon u to the left and 3 minus u. And then if you cross multiply, so 2 is equals to 3u minus u square. Now let's take everything over to the left. U square minus 3u plus 2 equals to 0. And then solve this using middle term breaking. So you have u square minus 2u minus u plus 2 equals to 0. And then if you take u common, u minus 2 minus 1 common, u minus 2 equals to 0. So after skipping a few steps, you will reach the conclusion that u equals to 1 or u equals to 2. Now is that it? Is that the final answer, or is there something else that we need to do? Yes, inshallah, Rayan, I plan on having streams like these every day. Maybe one for math and one for add math. And when math paper is closed, we'll have 2 streams for math, and then onwards we'll have multiple streams for add maths, inshallah. अच्छा मुझे ये बताएं कि is this it? Is this the final answer, or is there something else that I need to do before I get to the final answer? We need to find x. Yep, remember, we set out to find out the value of x. Okay, u was like, you can say, u is what's going to help us find out the value of x. Now remember, our substitution was log x base 2 is equals to u. So now log x base 2 is equals to 1, or log x base 2 is equals to 2. Now if you solve this, you have x is equals to 2 to the power 1, which is 2. And then if you solve this, you have x is equals to 2 to the power 2, which is 4. And there you go. That's your answer. Okay. अभी एक indices का सवाल है. We're going to skip that, but let's do this. Okay. Let's solve this. Now tell me, what exactly should I use over here to solve this? Sir, बहुत मुश्किल है. नहीं, ये मुश्किल नहीं है. Oh, okay. I trying to do. That was a pun. Nice pun. Will you be streaming once a week after May, June for us October, November students? Yeah, I can do that. Achha, okay, now listen up. First of all, let me tell you one thing that you can't do. You can't write this as log y minus log 15. Okay, you can't do that. You can't separate it like this. Okay, or you can't even do it like this. Log y LGY upon LG15. ये भी नहीं कर सकते आप. ठीक है. So what we'll have to do is we will have to first of all for these two. अब देखो इसको solve करने के दो तरीके हैं. ठीक है. I'm going to put both the methods in front of you, and then you guys can stick to whatever method you want. Okay. One method is that we change the two. Okay. We change the two to LG. Now these two in any case, irrespective of whatever method I use, these two in any case can be simplified using product law. Okay, so product law says that when you have two log functions with the same base that are being added, that means you can multiply their arguments. So using product law, I can simplify this, and what is this equal to? This is equal to 2. So that means LG y square minus 15y equals to 2. Now if you recall, the base of LG is what? The base of LG is 2. Okay, so if the base, sorry, not 2, it's 10. The base of LG is 10. So you can convert this into index form now and then solve it. If you convert this to index form, that means y square minus 15y will remain as it is, and then after the equals to sign, you will have 10 square. And what's 10 square equal to? 10 square is equals to 100. And then you can make a quadratic equation out of it and then solve it for the value of y. ठीक है. अच्छा, अब क्या वैल्यू आएगी, कौन सी वैल्यू एक्सेप्ट करेंगे, कौन सी वैल्यू नहीं करेंगे, विल टॉक अबाउट दैट इन अ मिनट, बट लेट्स फर्स्ट अंडरस्टैंड व्हाट द अदर मेथड इज. नाउ इन द अदर मेथड आल्सो यू विल फर्स्ट हैव टू मल्टीप्लाई द टू आर्ग्यूमेंट्स which will make it y into y minus 15. But in this method, what you can do is you can take this 2 and convert it to LG. That means you first write it as 2LG10, okay, and then inside on the left hand side you have LG y square minus 15y, and on the right hand side you have LG 100. Why LG 100? Because 2 then turns into the power of 10, and then you can ignore LG on both sides. Okay, it's not like they get cancelled or anything. We say okay, we're ignoring them. Okay, so y square minus 15y equals to 100. Then you can shift 100 over to the other side. Y square minus 15y minus 100 equals to 0, and then solve. Okay. Now then if you solve it, so I'm going to save some time and use a calculator over here. So you have 1 minus 15 minus 100. So we're looking at y is equals to 20 or y is equals to minus 5. Now what value of y are we going to take and what value of y are we not going to take? Yes, CB, your answer is correct. We're going to take the positive value because if you go back to the question, notice that you have LGY. Okay, so since y is the argument, it has to be positive. So we will write down both the answers, but when we're writing down the final answer, the acceptable answer, we take y equals to 20. And there you go. That's your answer. Now, any questions? Okay, let's move on. Sir, will you upload the previous maths differentiation stream? What stream are you talking about? Okay, you guys want to try and solve this question? Thank you, Ramesh. Rayan, but I think I already answered that question. And I think you acknowledged it as well. Okay, I don't know if you did, but yeah, we will have streams like these every day. Walaikum salam. Thank you, Master Chief. Master Chef to Sunata. What's Master Chief? Okay, solve this question, please. Let me know when you guys have the answer. Main topics for paper 2 पे video आ जाएगी. Don't worry about it. I'll make a video. I plan on making a video tonight and hopefully posting it by tomorrow. Sir, is it important to show your middle term breaking? Yes, yes. Make sure to show middle term breaking in the exam. Okay, so let's move. Let me solve this question. Anyone who'd like to give me the answer to this? Six and 3. Okay, let's find out. So it says that given that log p cube base a equals to 9 and log p square cube base a equals to 15. Achha, have a look at the marks also. This is a 4-mark question, okay? And you're asked to find out the value of log p base a and log q base a, okay? So that means we'll have to sort of split this, okay? Now, if you can see in the argument you have pq, that means there's some rule that has been used, right? And what rule has been used? It's the product law, okay? So if I want to separate this, so I can write it like this: log p base a plus log q base a equals to 9. Okay, so it's the same rule except that it's working in the different direction. Achha. Then if you look at this statement over here, which says log p square q base a equals to 15, so we can split this as well. Log a p square q equals to 15. So first of all, let's start with p square q. So I can write it like this: log a p square plus log q base a, okay, which is equal to what? Which is equal to 15. Then 2 gets multiplied, okay. So if 2 gets multiplied, this is what we're looking at. We're looking at 2 into log p base a plus log q base a, which is equal to what? Which is equal to 15. So technically what do we have? We have simultaneous equations. Okay. Now if you want, you can replace log p base a, you can call it x, and you can call log q base a y. Okay, or in fact that's what I'm going to do. That's what I would prefer to do. I'm going to call this x, and I'm going to write this down. Okay, let log p base a equal to x and log q base a equal to y. Okay, so in that case, here's what we have. We have x plus y, which is equal to 9, and we have 2x plus y, which is equal to 15. Now you can use whatever method you want. I'm going to go with elimination. Okay, so this becomes 2x plus 2y, which is equal to 18. So we have 2x plus 2y, which is equal to 18. Subtract kar le inko. Okay, so what you have as a result is minus y, which is equal to minus 3. So that means y is equals to 3. And remember, what was y equal to? Y was equal to log q base a. So that's equal to 3. And then to find out the value of x, let's go back here. X plus y equals to 9. Now that you have the value of y, x plus 3 equals to 9. So what's x equal to? X is equals to 6. And what was x equal to? X we substituted for log p base a. So that means log p base a equals to 6 and log q base a equals to 3. And that's it. That's your answer. Okay, now here's part 2. Part 2 says, अब देखो अब इसमें क्या हो गया? What's happened over here? If you look at the question, that here you were asked to find out log p base a and log q base a. Here all of a sudden it's log a base p. Now if we talk about log a base p, log a base p is nothing but the reciprocal of log p base a. Okay, so since we already know what log p base a is equal to, so that means log a base p is equals to 1 upon 6. And then if you talk about this log a base q, so log a base q is nothing but the reciprocal of log q base a. So that means log a base q is equals to 1 upon 3. Yahi tha na? Haan. So that's it. You need to do 1 upon 6 plus 1 upon 3. And what's that equal to? Let's use a calculator for that. 1 upon 6 plus 1 upon 3, that's equal to 1 upon 2. And there you go. That's your answer. Easy. अब ये सवाल एग्जाम में आता तो आप लोग कहते हैं मुश्किल है. अच्छा, now this was the question that I gave you guys as question of the day. Okay, which you guys solved. Most of you solved. So if you want to solve this, we're going to convert this into index form. So x is equals to 4 to the power half. So x is equals to 4 to the power half, which means x is equals to 2. That's it. It was a 1 mark question. And yeah. अच्छा, अब इस क्वेश्चन को ज़रा थोड़ी skip करते हैं because it's similar to the question that we have solved. Okay, I'll tell you how we're going to do this. 2 will become the power on y, and then you will simplify and solve it. Okay, so I'm just going to skip this question for now. Let's do some other question. Okay, so let's solve this question. Right, log x base 27 as a logarithm to base 3. So that means we're going to use change of base law. Okay, so how exactly are we going to use change of base law? So you have log x base 27. This can be written as log x base 3 over log 27 base 3. नमाज ब्रेक बेटा अभी यहाँ पे नमाज हुई नहीं है, तो यहाँ पे जब नमाज होगी हम तब ब्रेक कर लेंगे. ठीक है, it's not Maghrib yet in Karachi, but as soon as it is, we'll take a break. Okay, so what about log x base 3? Log x base 3 remains as it is. Log 27 base 3 को हम क्या लिख सकते हैं? Log 27 base 3 को हम लिख सकते हैं as 3. So there you go. That's your answer. Log x base 27 as a logarithm to base 3 can be written as log x base 3 upon 3. Now you'll see this written all sorts of ways in the marking scheme. You'll see this written as 1 upon 3 log x base 3. Now that's also perfectly all right. Okay, how you write it, that's up to you. Okay, but yeah. Okay, let's do another question. Let's have a look at part B. Now I'd like you guys to try part B. I'll give you guys 2-3 minutes. When you have the answer, let me know. Okay, 125a. Let's see if that's correct. So let's start simplifying this. So we have log y base a, nothing we can do about that. Okay. But we can multiply this 3 by both the log functions. So if you multiply this 3 by both the log functions, here's what happens. We have 3 log 15 base a minus 3 log 3 base a plus 1. Okay. Then we have log y base a, which is equal to log 15 cubed base a. Now let's see what's 15 cubed. 15 cubed is 3375 base a minus 3 cubed. So what's 3 cubed? 3 cubed is 27 base a. Acha. Now, if you guys are thinking, okay, I should have taken the cube first and then divided, and then we could have done that also. Okay. I didn't think of that initially, but yeah, we could have done that also. Now you can use the quotient law. So 3375 divided by 27 gives us 125. So we have log 125 base a plus 1. What should I do about 1? So now notice what is the base that's being constantly used in the question? It's base a. So whatever I rewrite 1 as, it has to have log base a. Okay, you can't write 1 as some other base because you got to be able to simplify it. So if you want to be able to simplify it, you got to make sure that it has base a and nothing else. Now here's what I can do. Log y base a is equals to log 125a, again using quotient law, base a. So log a gets cancelled, and now we have y, which is equal to 125a as our final answer. So whoever gave 125a, that's the correct answer. Good job. Okay, let's do some other question. All right, this question looks kind of scary. So we'll come back to it. We'll do this later. I don't want to do a scary question immediately. But let's do this question. You have to solve the following equation. It's a 5-mark question. Let's see how we can solve this. So first of all, here we're not going to use substitution. The reason why we're not going to use substitution is because you have log 2 base x, but here you don't have anything that can be turned into log 2 base x or log x base 2. Okay, so we have to think of something else. We have to think outside the box. So here's what I can do. We have log 2 into 29x minus 15. Now I'm going to rewrite 3, and if I want to rewrite 3 using log with base 2, I'll just multiply it by log 2 base 2. Why? Because log 2 base 2 is equal to 1. If you multiply it by 3, it remains 3. Okay, now what should I do with this? Now at the moment, the base is in place of the argument is in place of the base. So what if I take the reciprocal? So I let the 2 be as it is, and then if I take the reciprocal of this part, then it becomes log x base 2, and that does the job. Why? Because now we have log with base 2 only. But there is still some simplification that's left. So this can be written as log 29x minus 15 base 2, which is equal to log 2 cubed, which is 8 base 2, plus log x square base 2. And now using, again, rules of logs, we can simplify this. So the right hand side can be written as log 8x square base 2. The left hand side can be written as log 29x minus 15 base 2. So this gets cancelled out. Let's write this nicely. 29x minus 15 is equals to 8x square. Let's shift everything over to the right hand side. So we have 8x square minus 29x plus 15 equals to 0. Now again, I'm going to save some time and use a calculator over here to solve this. So 8 minus 29 plus 15. So one value of x is equals to 3, and the other value of x that we have is equal to 5 upon 8. Now let's see which value of x we can take and which value of x we can't take. Now notice that we have 29x minus 15. So we're going to check both 29x minus 15. So we're going to apply both the values, and we'll see which value gives us a positive result, which gives us a negative result. So if you take x equals to 3, then things are pretty safe. 29 into 3, whatever that is, and then if you subtract 15 from it, so that's 54. So we're safe. Okay, it's positive. But what if when x is equals to 5 upon 8? Let's see. So 29 into 5 upon 8 minus 15, then also we're safe. Then we have 3.125, so we're safe. So that means both of these answers are acceptable. X equals to 3 and 5 upon 8. There you go. That's your answer. Now we're going to take a break over here. I'll let the stream be as it is. Okay, the stream is running. We're going to take a namaz break and then we'll continue. Okay, see you guys in 10-15 minutes. Okay, we're back. It's almost time as well. Let's resume. In fact, it is time. Let's resume. So this is the last question we solved, question number 12. Okay, and this is what we ended up with. Both the answers are acceptable. Let me check. Yeah, both the answers are correct. Okay, great. Acha. So question number 13, this is an indices question. Part B is also an indices question. Okay, so let's solve this. Question number 14. Let's see what this says. This is altogether a 4-mark question. In fact, no. 4 plus 2, it's altogether a 7-mark question. Okay, so let's solve this. So it says do not use a calculator in this question. I mean, even if you do use a calculator, there's no way they're going to find out. But the thing is, you don't really have to use a calculator over here. Okay. So you need to find out the value of minus log p base p, and there's a power on the argument. Okay, so 2 gets multiplied, so we're looking at minus 2 log p base p. Log p base p, as we know, is equal to 1. So minus 2 into 1 is equal to what? Is equal to minus 2. And there you go. That's it. That's your answer. Okay. Okay, I appreciate that, Bilal. So I have a question. This isn't for advanced. I wanted to ask for demonstration. 10th grade. But it depends on your syllabus. It depends on what you've done in school. Okay. All right. Now here's part 2. Part 2 says find LG 1 upon 10 to the power n. Okay. So what can I do with this? We can use quotient law over here. So we can write this as LG1 minus LG 10 to the power n. So LG1, what is LG1 equal to? As we saw earlier, that log, if it has argument 1, is going to be equal to 0. And this n gets multiplied. So n into LG10, LG10 as we know is 1. So we have 0 minus n, which is equal to minus n. And there you go. That's your final answer. So log differentiation के अलावा किस topic में आता है? Log differentiation में के अलावा integration में आता है. But you don't need to know how to learn integration of logs. You need to learn how to integrate functions that lead to logs, and ln mostly, not just logs. Okay. Okay, then it says, here's part 3. Show that log 20, LG20 minus LG4 upon log 10 base 5 is equals to LGY square. Okay, so let's see what we can do over here. So first of all, as far as the numerator is concerned, it can be written as LG20 upon 4 using quotient law. And as far as the denominator is concerned, okay, so we'll let the denominator be as it is for now. We'll let the denominator be as log 10 base 5, okay, but we'll do something to it later. Now, 20 upon 4 can be simplified and written as 5. So now we're looking at LG5 upon log 10 base 5. Now, we can use change of base law. We can use change of base law over here. So let me rewrite this. Using change of base law, I can write this as LG10 upon LG5. Okay, so this has turned into this using change of base law. And what's LG10 equal to? LG10 is equals to 1. So that means this is what we're looking at. LG5 divided by LG10 upon LG5. So if we turn division to multiplication, then it becomes LG5 upon LG10. LG10, as we know, is equal to 1. So now we're looking at LG5 into LG5, which is equal to LG5 whole square. Now please remember, do not write this as LG25 or do not write this as 2LG5. LG5 whole square will remain LG5. Okay, that's what the question is also saying, that you're supposed to write it like this. And what's the value of I? Not that you have to write it separately, you just have to simplify this and write it like this. And that's it. That's where your job ends. Okay, now here's part 4. This is a 2-mark question. Now this is a fairly easy question. So first of all, you have log with base r. So using product law, you can multiply the two arguments, 2x into 3x, which is equal to what? Which is equal to log base r, 600. So log base r gets cancelled out. Not cancelled, we just ignore it. So 6x squared is equals to 600, which means x squared is equals to 100, which theoretically means x is equals to plus minus 10. But we're only going to go with 10 because, as you can see, that 2x and 3x are part of the argument, so we have to keep them positive, and x equals to 10 is the value that's going to keep them positive. So there you go. That's your answer. Sir, are 15 year? Okay, yes, Bilal, 15 years ke past papers are enough. Okay, now you can please stop spamming now. Sir, I'm expecting 55 marks in Math P1. Okay. That's less. 55 marks is less. Khair, ab what's happened is happened. You should be aiming for 85 plus in P2, to say the least. 85 plus for sure होने चाहिए. Wish you were my teacher. Well, technically I am teaching you through YouTube. ऊपर product law क्यों लगाया? Okay. क्यों लगाएंगे product law? You can see that you have log with same bases that are being added. So what happens when two logs with same bases are being added? What do you do with the arguments? You multiply them. That's what I've done. Product law. Okay. Hashim beta क्या नहीं समझ आ रहा? Can you narrow it down a little? Okay, so let's solve this question. So you have 2 to the power 3x minus 1, which is equal to 6. Now, because you have 2 to the power 3x minus 1 and 6, you can't write 6 as a power of 2. Okay. ऊपर वाले part में क्यों नहीं लगाया? अच्छा चलो, we'll go back to it. First, let's solve this. Now, because you can't write 6 as a power of 2, so what do we have to do? We have to use LG over here. Okay, so we apply LG on the left hand side, LG 2 to the power 3x minus 1, and we apply LG on the right hand side as well. 3x minus 1 gets multiplied, so we have 3x minus 1 into LG2, which is equal to LG6. Now, step by step, let's start making x the subject. 3x minus 1 is equals to LG6 upon LG2. 3x is equals to LG6 upon LG2 plus 1. And then in the end, x is equals to LG6 upon LG2 plus 1 divided by 3. Now keep it in exact form till you get to the once till you've made x the subject, and then just use your calculator and plug it in and then figure out your answer. Okay, I forgot to write LG over here, and please do not make the mistake of simplifying this 2 with this 6. Okay, don't make the mistake of doing that. So the answer is 1.19, that's correct. X is equal to 1.19, correct to 3 significant figures. So there you go, that's your answer. Okay, now I'm going to skip part 2 because we've solved a question similar to it. Now I want to solve as many unique questions as possible, okay, to maximize learning. Okay, let's solve this. This is a nice question. We have log x base 3 plus log x base 9 equals to 12. Okay, I'll give you guys a few minutes to solve this. Okay, if you guys are able to do it, that's great. Let me know the answer. If not, then we're gonna solve it anyway, so don't worry about it. Sir, in previous question, LG5 whole square समझ नहीं आया. That's because we multiplied LG5 with LG5. So if you're multiplying LG5 with LG5, that means it's LG5 whole square. It's just like if you're multiplying x with x, what is that equal to? It's not equal to 2x, right? It's equal to x square. So just like that, if you're multiplying LG5 with LG5, it's going to be LG5 whole squared. Sir, even if I learn like the rules and practice questions, the problem that advanced like last 2 years, it's so tough. So beta, you don't look at the last 2 years of past papers, right? I mean, all be the past papers. And what about before? What about 2020? 2020 paper was not that difficult. And then before that also. Well, when you're solving 2019 and before, just make sure to not do any questions of matrices, not do any questions of relative velocity. So if the paper is difficult, then I shared that Excel file where you can calculate your grade after the threshold is applied. So if you're solving a past paper and you're not getting good marks in it, it's okay. See what grade you're getting after threshold has been applied. Okay. So yes, it's possible. If you look at your absolute grade without applying the threshold, then you will end up feeling demotivated. Before 2021, it was okay, but last 2 years was difficult. Yeah, the last 2 years have been difficult. I agree. Okay, 6561, is that the answer? 6561? Okay, let me check. Oh yeah, that's correct. 6561 it is. Good job. Good job. Good job. Thank you, Adina. Appreciate it. So can you do past papers based in? Yes, I will do kinematics as well. Don't worry about it. Okay, now, how do we solve this? How do we solve this question? Well, first of all, a question like this is best done using substitution. Okay. Now notice you have log x base 3 over here, and notice you have log x base 9. So here's 3, here's 9. Okay, there's something similar with these two. Okay, 3 and 9. 9 is a power of 3. So here's what we can do. We can use substitution and we can say, okay, let log x base 3 be equal to a. Okay, let log x base 3 be equal to a. Okay, now we'll put this on the side. Okay, and we'll see how we can rewrite log x base 9 so that we can see log x base 3 somewhere. So log x base 3, we'll let that be as it is, but as far as log x base 9 is concerned, here we have to use change of base law. So I can rewrite log x base 9 by using change of base law as log x base 3 divided by log 9 base 3. Okay, and what's log 9 base 3 equal to? That is equal to 2. Please note it's not equal to 3, it's equal to 2. Why? Because 3 square is equal to 9. Okay, so this is equal to 2. So that means this is what we're looking at. We're looking at log x base 3 plus log x base 3 upon 2, which is equal to 12. Now you don't really have to use substitution, but substitution से फ़ायदा ये होता है कि ज़रा थोड़ा neat हो जाता है question. Okay. So a plus a upon 2 is equals to 12. Now if you solve this, a plus a upon 2 का मतलब है 1.5, so that's equal to 3 upon 2a. So 3 upon 2a equals to 12, and then if you solve for the value of a, so 12 into 2 divided by 3, so that's equal to 8. So a equals to 8. At this point, please don't get carried away. Remember, you made a substitution. You said let log x base 3 equals to 8, so that means x now is equal to 3 to the power 8. Now, if you multiply, if you find out 3 to the power of 8, so that's equal to 6561. So 6561. Now, there are other ways of solving this question also, and I'm not in any way claiming that this is the best method, and you don't have to use any other method. You can, yes, you can multiply both sides by log 9. Okay, if that works for you, so go ahead. Okay, I personally like to use substitution, and that's what I encourage you guys also. But if you have a good grip on the other method, then it's fine. Perfect. Sir, can you do surds? I hate those. Surds is fairly easy. I didn't plan on doing surds. Do you guys want me to do surds? Let me know. Vectors, yeah, I do plan on doing vectors. I plan on doing kinematics also. But surds, मैंने plan नहीं किया हुआ. Okay, now we'll do this question also. This is from May, June 2019. This question basically became the talk of, you know how there's one question in every paper that everyone is just talking about right after the paper. So in May, June 2019, this was it. Okay, we'll come back to it later. And let me pick another question to solve. Okay, so I'd like you guys to try and solve this. We're skipping the indices part, but let's do this question. Hello. क्या हाल है आपके? If you guys are able to solve this question, then it's a pretty big deal. Okay, because ये एक tough question है. Yes, this will be posted. Don't worry about it. This will be posted. Is it worth resetting? Resetting for what? What exam do you want to reset? The exam that you missed? What are the marks needed for A star in O levels P1 this time? Well, the threshold is not out yet, but looking at the paper, if you're talking about math, then looking at the paper, I would say the threshold would be around 62 something, somewhere between 58 and 62. Okay, chalo. Let me solve this. So first of all, here's what we're going to do. Notice that the question says A is greater than 0 and B is greater than 0. Okay. Now, since we're not at the end going to end up with a value of A and B, so that means we don't really have to worry about this. I mean, this is not really going to interfere with our final answer. It's just trying to tell you that because this log function is, to keep this log function defined, A is greater than 0 and B is also greater than 0. Okay. It's like you're given the domain basically. So first things first, here's what we're going to do. We're going to rewrite square root of b to the as b to the power half, okay, minus 1 upon 2, which is equal to log a base b. Okay. Acha. Then what happens is that the half gets multiplied. Acha, at the same time, read the question. See what it's asking you to do. The question is asking you to solve this equation for b. So that means you have to give the value of b, and you don't have to give the value. In fact, you have to give it in terms of a. Okay. So let's multiply half in the entire log function. So this is what we get. We get half log b base a minus 1 upon 2, which is equal to log a base b. Acha. The thing is, here you have log b base a, here you have log a base b. So before we can simplify this, we have to make sure that the base is the same. So here's what I can do. 1 upon 2 equals, 1 upon 2 into log b base a. अब एक काम करते हैं, इसके साथ हम लगा देते हैं log a base a, okay, which is equal to 1 upon log b base a. Okay, so I've achieved what I wanted to by taking the reciprocal. And keep in mind that this is a 5-mark question, so that means there's a decent amount of working that's required. Okay. Okay, now let's see what happens on the left hand side. On the left hand side, half. Achha, wait, there's no point in making half the power. Okay, let's see what we can do over here. So we can use substitution over here. Is substitution a good idea? Okay, substitution is, well, it's not a bad idea. Okay, so here's what we can do. एक काम करते हैं, on the left hand side we can write it like this: log b to the power half, let's rewrite it as square root base a, okay, minus log root a is equals to 1 upon log b base a. Okay. Now on the left hand side you can see that we can use change of base, we can use quotient law. Okay, we can use quotient law on the left hand side. Okay, so if I use, yes, we can take half common. Okay, that's also not a bad idea. We can take half common. Okay, but on the left hand side, if I use quotient law, here's what I end up with. So inside the square root we have b upon a. Okay, and this is what we have on the right hand side: 1 upon log b base a. Okay. Okay, now so from this point, here's what I can do. Okay, if I use substitution, will that work? No, substitution will not work. Just a second. मैं ज़रा इसका आंसर कंफर्म कर लूँ. Okay. Now, so here's what I can do. I think हमें यहाँ पे substitution use करना is a good idea. Okay. So अगर हम substitution use करेंगे, so this is what we end up with. एक काम करते हैं. Let's go back and इसको यहाँ से दोबारा solve करते हैं. So let's take half common over here. So if I take half common, here's what happens. We have log b base a minus log a base a, which is equal to 1 upon log b base a. ठीक है. अच्छा, I'm gonna take half common. So I'm gonna do a substitution over here, and I'm gonna say let log b base a be equal to p. Okay. अच्छा, और मैं वापस से इसको 1 बना रहा हूँ. ठीक है. So 1 upon 2 into p minus 1 is equals to 1 upon p. ठीक है. 1 upon 2 into p minus 1 is equals to 1 upon p. Now if you cross multiply, so we have p square minus p, which is equal to 2. ठीक है. We've cross multiplied p square minus p equals to 2. Now if you take everything over to the left hand side, p square minus p minus 2 equals to 0. Now let's solve this like you would solve a quadratic equation. Okay. And if you solve this like you would solve a quadratic equation, here's what you're going to get. 1 minus 2. So p is equals to 2 or p is equals to minus 1. Okay. Now, let's go back to whatever we substituted. We said let log b base a equals to p. So log b base a is equals to 2 or log b base a equals to minus 1. Okay. अब हम solve कर सकते हैं. So b is equals to what? B is equals to a square, or b is equals to what? B is equals to a to the power minus 1. Did we have to make a the subject or b the subject? No, we had to make b the subject. So there you go. B is equals to a square, or if you want to write this as a positive power, so b is equals to 1 upon a. So there you go. थोड़ा challenging सवाल था, and there you go. That's the answer. Yes, it is a challenging question. I understand that. ठीक है. So good job, those of you who got it right. B is equals to a square and b is equals to 1 upon a. That's correct. So now let's do another question. Okay, now this is a fairly recent question. This is from October-November 2020, paper 2, variant 2. So let's solve करते हैं. So you have, this is logs as well as simultaneous. Okay, logs as well as simultaneous. And let's see what do we get. What calculator do I use? I use this calculator. It's FX991EX ClassWiz, Casio ClassWiz. Okay, and it is allowed. So don't worry. A lot of people might tell you it's not allowed, but it is allowed. Okay. So basically, before I can solve these simultaneous equations, we have to bring them in index form. Okay. So how do we do that? Here, if you use the conversion rule, x plus y can be written as 3 squared, and x plus y in this case becomes what? X plus y equals to 9. Okay. Achha. Then let's look at this equation over here. 2 can be made as a power of x plus 1. So now we're looking at log x plus 1 base 3 to the power of 2. So do we have to show a quadratic equation working? Yes, just show the middle term. If let's say you're using the quadratic formula, okay, then just plug in the values in the formula and then write down the final answer. If you're using middle term breaking, then just do the first step where you break the middle term and then you can write down the final answer. Okay, calculator is only to check your answer. The reason why I use it is to save some time. If I were doing an exam, I would also show the working. Okay. Yes, we cancel the logs and now we have x plus 1 the whole thing square, which is equal to y plus 2. Okay. Now, this is equation number 1. This is equation number 2. Let's make x the subject. Doesn't matter what you make the subject. Let's say we make y the subject. In fact, let's make y the subject. So y is equals to 9 minus x. This is the third equation. And this goes over here. So we expand the left hand side. X squared plus 2x plus 1, which is equal to 9 minus x plus 2. Now you get everything over to the left hand side. X squared plus 3x 1 minus 9 minus 2. Let's see what that is equal to. 1 minus 9 minus 2. So that's equal to minus 10 equals to 0. Okay. Now let's solve this. Again, we can do middle term breaking. So देखो अगर एग्जाम में ये चीज़ करो ना, here's how you do it. X square plus 5x minus 3x, sorry, minus 2x minus 10, okay, equals to 0. And then you can write down the final answer, which is minus 5 or x equals to 2. Okay, not 2 actually, x equals to, yeah, x equals to minus 5 or x equals to 2. Okay, alright, done hai. 50k pe giveaway done. Suggest ideas for giveaway as well, by the way. Now once you have the value of x, let's find out the value of y. Since y is equals to 9 minus x, let's see what do we get. So let's use x equals to minus 5. So if we use minus 5, we get 9 minus minus 5, which means y is equals to 14. And then if we use x equals to 2, so we get y is equals to 9 minus 2, which means y is equals to 7. अच्छा अब over excited होके दोनों answers ना दे देना, ठीक है? Go back to the question, see which value makes sense and which value doesn't make sense. So notice that x is equals to minus 5, and if x is minus 5, if we do minus 5 plus 1 over here, what happens is that it remains negative. So that means we're going to discard this. Now if x equals to minus 5 gets discarded, that means y equals to 14 also gets discarded. So now we're left with 2 comma 7. So the only solution, acceptable solution, is 2 comma 7. Give away my Lego pieces. No, never. I would never do that. इतनी मुश्किल से तो collection किया है. X equals to 2, y equals to 7. Besides, I don't think there are people are that crazy about Lego. Give away a scientific calculator. Oh, you can do better than that. I'm not going to give away a scientific calculator. Q&A at 50k. Well, we don't have to reach 50k for that. I can do a Q&A without that as well. Giveaway sounds more appealing. खैर एक और सवाल करते हैं ज़रा. चलें आप लोग ये क्वेश्चन सॉल्व करें, ठीक है, and then we'll do part B also. Part B and part C. ये एक अच्छा question है, comprehensive question है. And then we'll do that question which I skipped earlier, where I said कि ये पेपर का थोड़ा मुश्किल सवाल था, the one which involved sign, and then that will be the end of it. Give away a t-shirt with your logo. That's not a bad idea. Chalo, we'll figure something out after the exams, inshallah. Sir, where can we cancel log and where can we not? So remember the rule over here. If you reach a point where you have a single log function, okay, with an argument and on the left hand side, and then if you have a log function with the same base as on the left hand side, and it has to be a single log, nothing with plus, minus, multiply, divide, nothing like that, then you can cancel the log and compare the arguments. Okay, so p equals to 16, p equals to 4. Okay, so Hasib says 16, Shazia says 4. Okay, why do we have a disagreement here? 16 or 4? Make up your mind. So we can use, so we're using two rules over here, the product law, which means p into 5, and then at the same time the quotient law, which means divide by 4, equals to what? Equals to log 20 base a. So log with base a gets cancelled out, and now we have 5p over 4, which is equal to 20, which means 5p equals to 80, which means p is equals to 16. Okay, perfect. Okay, now don't solve part B, but tell me what exactly are we going to do in order to solve part B. 16 is the correct answer. Yep, good job. You're welcome, Tahir. Okay, that's correct. We're going to substitute 3 to the power x. So basically, we see something common in this question, and that is 3 to the power x. Okay. So we'll say let 3 to the power x be equal to a. Okay. But before I can substitute, because before I can replace 3 power x with a, I need to isolate 3 power x or bring out 3 power x from 3 to the power 2x plus 1, for which we're going to use rules of indices. So 3 to the power 2x plus 1 must have happened because of 3 power 2x into 3 power 1. Now here the 3 power x can easily be replaced by a. Okay, अब इसका क्या करें? 3 power into 2 power x can be written as 3 power x to the power 2 into 3 plus 8a minus 3. Achha, this is not equals to a. I don't know where that came from. It's equal to 0. So a square into 3 plus 8a minus 3 equals to 0, which means 3a square plus 8a minus 3 equals to 0. Okay, now you can do middle term breaking over here. 3a square plus 9a minus a minus 3 equals to 0. अब इसके बाद आप फाइनल आंसर चाहें तो लिखते हैं, ठीक है. So 3, 8 and minus 3. So one value of a that I'm getting is 1 upon 3, and the other value of a that you will get is minus 3. Now go back to the substitution. 3 power x is equals to 1 upon 3. Now thankfully we don't have to use logs over here. When it's likely that you might have to use logs, we can simply use the change of base law from indices. So 1 upon 3 can be written as 3 power minus 1. So x equals to minus 1. And then 3 power x equals to minus 3. This is not possible. Okay, this is something that's not possible. So x equals to minus 1 it is. That's your final answer. Okay, now solve this. This is a 3-mark question. And then we'll move on and solve the last question. Y equals to 4. All right, let's find out. So again, here also I would advise to use substitution. So this, if you take the reciprocal, can be written as 4 upon log y base 2. Okay. In fact, wait a minute. ये तो भूल ही गया मैं कि you have a 4 just before the log function. So this becomes log 2 to the power 4, which is 16, plus log y base 2, which is equal to what? Which is equal to 4. Okay. Now you can use change of base law over here. इसको आप लिख सकते हैं as log 16 base 2, ठीक है, and log y base 2 plus log y base 2 equals to 4. So I would prefer to use substitution over here. I would say log y base 2 को मैं a के बराबर ले लूँ. Log 16 base 2 is 4. So 4 upon a plus a equals to 4. And then if you take the LCM, here's what happens. You have 4 plus a square, which is equal to 4. So we have a square plus 4, which is equal to 4a. A square minus 4a plus 4 equals to 0. And now if you solve this, a is equals to 2. But again, don't get carried away. Log y base 2 is equals to 2, which means y is equals to 4. Y is equals to 4 is your final answer. Okay. Now, if you didn't want to use substitution, if you wanted to do it some other way, go ahead. It's just that I prefer substitution. Okay. Now, the one last question, and that is going to be this. That is going to be this question. So now I'd like you guys to do part A, and then let's do part B. Okay, fine. Chalo, go ahead. Do this question first if that's what you want. It was quite difficult. It was quite difficult, but then again, if the paper is difficult, you know what happens. That means the threshold will also be low. So yeah. Lag? Really? Okay, anyone who has the value of k? -1? I don't know. Let's find out. So this is question number 39. K is -1. That's correct. Okay. So let's solve this. Let's see how many marks this is. It's 3 marks. Okay. So first of all, sine 2x plus 5 gets multiplied. So we're looking at sine of 2x plus 5, which is getting multiplied by ln a. Now, as far as ln 1 plus a is concerned, we're left with sine 2x plus 5 ln a minus ln a upon ln a. So what you can do is you can take ln a common from the numerator. If you take ln a common from the numerator, you have sine 2x plus 5 sine 2x plus 5 minus 1, and don't forget that the denominator is ln a as well. So ln a gets cancelled out, and now we have sine 2x plus 5 minus 1 as your answer. Okay. And then let's solve this question also while we're at it. Remember, the base of LG is 10. So 10 to the power 0 is equals to 1. So that means x square minus 3 equals 10 power 0, which means x square minus 3 is equals to 1, which means x square equals to 4, which means x is equals to plus minus 2. And you can have both as acceptable answers, plus 2 or minus 2, because you have x square. Had it been just LGX, and we would have ended up with 2n minus 3, or 2n minus 2, we would have gone with 2. So there you go. That's it. Okay, so yes, you guys are right. I don't know why it's lagging. But okay, I'm going to stop here anyway. And I hope this stream helped you guys. So I'll see you guys in the next stream, inshallah, which will be tomorrow. Tomorrow also I'll be doing a stream on math and a stream on add maths. I'll post on my Instagram as to. Okay. अब सही है वैसे? Can you guys hear me? Now I'll share this file. I'll share the solved version of the past papers, and I will also share the notes so you guys can download it from there. So the internet speed is not up to the mark. I don't know why. But yeah, I'm going to stop here anyway. So I'll see you guys in the next class, in the next stream actually. Take care. Allah Hafiz.